So we are going to move on from long division to now we're going to learn how to sketch polynomials. And so there's a couple things we need to know first before we learn how to sketch polynomials. So bear with me because I think when we first address this stuff, you'll be confused. And then after I go through some examples, it will start to make more and more sense, as opposed to me just explaining it and you going, that was a great explanation, Ms. Rice, thanks. I totally understand it now. Test me right now. You know what I'm saying? Like it's going to take a little bit. Okay. So the first thing we need to know to do today's assignment is we need to know what the degree of a polynomial function is, and the degree of a polynomial function is the highest exponent. The highest exponent. So if you had a problem like y equals negative x squared plus 5x to the 4th minus 3x to the 17th plus 2x minus 11, you would ignore everything else and you would look for the highest exponent and you would say that this function has a degree of what? 17. Okay. And the degree always comes in the standard form. We think of it as the highest exponent. So if we have something in factored form, like if I have x plus 2 times x plus 1, what would the degree of this function be? It would be a degree of 2 because I have to picture what would happen if I FOILed it out. Does that make sense? I have to think about what would happen if I FOILed it out. And if I FOILed this out, I would get an x squared. And so that tells me that this is a degree of 2. Okay. So when we have something in the factored form like this, we put an exponent with the factor. So this parenthesis does not have an exponent. That means it really has an exponent of 1. And this parenthesis does not have an exponent. That means it really has an exponent of 1. And then we just count our exponents. 1 plus 1 is 2. And that's how you can find the degree quickly if you're doing a factoring problem. Okay? Right. So the degree is the highest exponent. We say that when it comes from something in standard form, it's really easy. Just look for the highest exponent. That's the answer. Today we're going to be dealing with factored form, and so we're going to have to count the exponents to figure out what the highest degree would have been if you had FOILed it out. Okay? We are not going to FOIL it out. That's a later day. Aren't you excited for the foiling day? Oh, I love the foiling day because everybody whines so much. It's not going to be today. Sorry. All right, so linear functions, overall, they look like this, right? They go straight, bloop. That's a linear function. Yep. And that's when we have an x to the first power, and that's all we have. Okay. Next, we have quadratic or even functions. And what does a quadratic function look like? A parabola, right? So a quadratic function looks like this. So let's go ahead and draw a little sketch of this. Drew. All right, and then if I do x to the 4th, anyone know what an x to the 4th graph looks like? It's the same, it just grows faster, so it looks a little skinnier. Okay, so let's go ahead and draw that. Looks like this. Anyone have a guess about an x to the 6th graph? Even skinnier because it grows even faster. But not a whole lot skinnier, just a little bit skinnier. Okay, something like that. So x to the 2nd, x to the 4th, x to the 6th, etc. So if you have a polynomial function that just has a degree of 1, then that's going to be a straight line. If you have a polynomial function that has a degree of 2 or 4 or 6, then if you were to completely zoom out on the graph, like zoom all the way out, it's going to overall look like a U shape. It could be funky down here, like there could be some squiggles down here, but if you like zoom out and look at it from far away, it's going to look like a U shape. It could be right side up like this, or if there's a negative in front of the equation, it could show up upside down. Okay, so that's what even degree functions look like. So now if we look at a function that has an odd degree, anyone remember what the odd degree functions look like? Cubic? We've done this one before. Yeah, they call it an S-curve. I don't know why, because it doesn't quite look like an S, but I guess you get it. So here's a cubic function. We have half of a u going down and half of a u going up. What do you guys think an x to the 5th function looks like? I love it when you guys are this engaged. It's wonderful. Yeah, same thing, but steeper because it grows faster. So x to the 5th looks like this. X to the 7th looks like this. So when we do these graphs, if you were to zoom out, they would have that general curve if they're an x to the 3rd, x to the 5th, x to the 7th. So whatever the degree is, it's going to look like that overall. It could have a negative in the front, so it could kind of go the opposite direction where it could start here and then go the other way. Okay, so for end behavior, this is the one time the whole year I'm going to let you write end behavior only using arrows and not using the sentence. Okay, so end behavior, we typically say as x goes to negative infinity, y goes to whatever, as x goes to positive infinity, y goes to whatever. Here, we're only finding the end behavior to help us draw the sketch. And since we're only using it to help us, we don't have to write it formally. We can just write it the way that makes sense to us, okay? So we have 4 options. We can have an even degree with a positive coefficient. What does coefficient mean? The number in front, okay? So if I look at this term right here, 17 was the degree. 17, that term that had the 17 degree, has a negative coefficient because it has a -3 in the front, okay? This factored form had a positive coefficient. I can tell because there's nothing in the front making it negative. It's just space, so that's a positive, okay? So if you have an even degree and a positive coefficient, then your graph goes up, up, like this. Okay, so your arrows would be up, up. If you have an even degree with a negative coefficient, that would take this graph and it would flip it upside down. And so what way would your arrows go? Down, down. All right, over here, this is where we have an odd degree. So if we have a positive coefficient, then that means the arrow goes down first and then up. And the reason this makes sense is because if you think about going from down first, then up, and you take away all the curve of the graph, it looks like it's got a positive slant. And so that's reasonable, right? If you were to put a negative in the front, this part would go up here and this part would go down here, and that would give us a negative slant. Does that make sense if we flip it? And so an odd degree with a negative coefficient would go up first and then down because that's how it gets that negative slant to it. Okay? So the way that I like to phrase this is I say you can tell it's an even degree because the arrows go the same direction, or you could say the arrows agree with each other, they're the same. And you know it's an odd degree because the arrows are at odds with each other. No? Okay. Tough crowd, tough crowd. All right, so next, we also can look at what we call the multiplicity of the x-intercepts. So what I just described to you is like the overall shape of the graph. That's if we zoom out completely and we're looking at the graph from super far away. If we zoom in and we're looking at just what's happening at the x-intercept, so we are like super zoomed in, it'd be like taking someone's face and putting it right here in front of your face and looking at like what their eyelashes are doing. That's what we're doing when we find the multiplicity and draw the roots. So anytime we have an x-intercept with a multiplicity of 1, so this would be like in parentheses we might see x minus 2 or we might see x plus 5, but the factors are always written like that with an exponent of 1. Anytime we see an x-intercept with an exponent of 1, that means that at the x-intercept it went straight through because it's linear, so it just goes straight. Okay? If the x-intercept or the factor has a multiplicity of 2, so this could be like x plus 2 squared or x minus 1 squared or x squared, and these could be to the 4th exponent or the 6th exponent or the 8th exponent, we just only deal with 2. So it could be 4 or 6 or 8, but we are always going to say 2 because we always do the most simple case. So if it's a squared, then it would look like a mini parabola on the x-axis. So it could be a mini parabola going up, or it could be a mini parabola going down. So the individual shape, if you zoom in and look at the x-intercept, is the same as the overall shape if you zoom out, okay? And that's because x squared always means U-shape. Whether you zoom in or zoom out, you're going to see a U-shape, okay? Multiplicity of 3 could be something like x to the 3rd, or x plus 7 to the 3rd, or x minus 12 to the 3rd. Something with an exponent of 3. Again, it could have an exponent of 5 or 7 or 9, but we always deal with the smallest version. Okay, and so these have that S-curve. So the way that I draw these is I say go up, level off, go up. Or you can say go down, level off, go down. And when you hear me talk about these, I will talk about these in 3 different ways to help you make sense of them. So multiplicity of 1, I will say it goes straight through. A multiplicity of 1 would go straight through. A multiplicity of 3, I'm going to say squiggles through. Does that make sense, the difference between straight through and squiggles through? Yeah. And then this one, we say it bounces. It hits the x-intercept and bounces off. So you want to come up and get a page for notes? Okay. So what we're going to do is we're going to look at some pictures of graphs, and we're going to see if we can recognize how to write the equation for the graph, okay? And we're going to refer back to these notes. So leave these notes out on the table. You're going to need them today, okay? So here is a picture of a polynomial graph. The arrows go opposite directions. They're at odds with each other. So is the function going to have an odd degree or an even degree? It's going to have an odd degree. The arrow goes down first and then up. So is it going to be positive or negative? Positive. Okay, so we have an odd degree. It's positive. Can you guys tell what the x-intercepts are? Positive 5 or negative 5. Negative 1 maybe? Negative 2? Negative 1, negative 2? And like positive 3? Okay, so I'm going to go ahead and say that's negative 5. We'll say this is negative 2. We'll say that's positive 3. Okay, so if I start writing the equation, I would say y equals, we decided that it was positive in the front, right? And then in parentheses, what should I write for an x-intercept of negative 5? X plus 5, because we do the opposite sign in the parentheses. So x plus 5, and if you cover everything else up and you look just at the x-intercept, does that go straight through or does it squiggle through? Straight through. So that's a multiplicity of 1. You can put the 1 in the exponent or not put the 1 in the exponent, it doesn't matter. All right, what should I put next? X plus 2. Does that go straight through or does it squiggle through? Straight through. Okay, and then what do I put last? X minus 3. Straight through. Okay, so if we look at this, what's the degree of this function? 3. 1, 2, 3. Degree of 3. So it's odd, like we expected, and it goes straight through, straight through, straight through. Does that make sense how I came up with that? Okay, we're going to try another one now that you understand it a little bit better. Okay, here is the next one. Okay, what do you guys notice? Yeah, we have one that squiggles. You see the difference between straight through and squiggles through? Straight through, squiggles through, okay. We don't have a parabola one because this looks like a parabola, but it's not on the x-intercept. This is a parabola, but it's not on the x-intercept. And so it's kind of like you zoom in and you only look at the x-intercept, and when we look at both of those, they're both straight through. Yeah, that's a good question. Okay, so is this even degree or odd? Odd, okay. Is it positive in the front or negative in the front? The arrow goes down first, then it goes up, so compare it to your notes. Positive or negative? Positive. If I look at just the arrows, it goes from down to up. Does that look positive or negative? Positive, that's slanted up, right? Like if you walked that, you'd be going uphill. Okay, so it's positive. I'm going to write y equals, go ahead and write down the equation on your paper. Write down what you think it is on your paper. Oh shoot, you guys got to open your eyes now. Dang, so rough. So we're going to have 3 sets of parentheses because we have 3 x-intercepts. We got to figure out what we put in the parentheses for this one. It squiggles as it goes through, so it's going to have an exponent. This one goes straight through. This one goes straight through. All right, so what do you guys have for the first parenthesis? X plus 3 cubed, because it squiggles through, so that's a multiplicity of 3. All right. What do you have for the next set of parentheses? X minus 4 to the 1, because it goes straight through. And then what do we have for the last one? X minus 7 to the first, because it goes straight through. And then we have, it's positive in the front. It's a degree of 5. Okay, let's try this one. So again, we're going to write the equation on our papers. Both arrows go down. What does that tell you if both arrows go down? It's even, because the arrows are the same. It's even. They both go down. Awkward silence. They both go down. It's negative. So we're going to say y equals, we got to have a negative right in the front of our equation. Okay, if you ignore everything else and just look at that x-intercept, does it go straight through? Does it bounce? Or does it squiggle through? It bounces. So what does that mean if it bounces? It's squared. Okay, what about that one? Straight through, bounce, or squiggle through? That's a squiggle through. What about that one? Straight through. Okay, go ahead and see if you can write the equation. So again, we're going to have 1 set of parentheses, 2 sets of parentheses, third set. So 3 sets of parentheses. We have a bounce, a squiggle, and a straight through. Anyone want to share what one of their sets of parentheses was? Okay, x plus 4 what? Squared. I'm putting it in the middle because you don't have to write it first, even though it comes first. Okay. What should I put next? X plus 1 cubed, so that's this part that squiggles through. And x minus 1 to the first power. Now, if you want, you can always put the 1 in there, but you don't have to. Okay, can you guys tell me what this degree is? 6. 3 plus 2 plus 1 is 6. Okay. How easy do you guys feel like these are? Pretty easy? Okay. Watch girl. This one. Okay. Even degree or odd degree? Even, because both arrows go up. Should it have a positive in the front or a negative in the front? Positive, up arrow, so I'm not going to put anything in the front. How many sets of parentheses do I need? So 1, 2, 3, 4. Okay, go ahead and fill in your parentheses, see what needs to be there. Yeah. This number down here, it doesn't matter because this one doesn't count. So you only care about these 4. That's a good question though. Did you guys catch that? We don't care about this one down here. That's a y-intercept, not an x-intercept, so we ignore that. Okay. So what should I have in my parentheses for that one? X plus 2 squared. I'm going to put it on the end. All right. Somebody other than Christian. Sorry, Christian. What should I put for this one? Yeah. X plus 1 cubed. Okay. I'm skipping that one. What should I put for this one? You're close. X minus 1 squared. Perfect. That's a mistake I make all the time. And then the last one, x minus 2 to the first, and the degree is 8. 3, 4, 5, 6, 7, 8. Perfect. All right, do you feel like you can do some of these without sitting here awkwardly doing them as a class? Okay, so I have a packet for you, and look how many fun graphs are on it. Oh, so here's the thing students often forget. They forget to put the y equals in front. Don't forget the y equals. Make sure you have it, okay? They also sometimes forget to put a negative in front. So make sure you look to see if it should be positive or negative. And then don't worry, folks, we're going to draw our own as well. That's coming next. All right, so what I'm going to do first is I'm going to say this one does not have an exponent. So what exponent should I write? A 1. And then if I want the degree, I'm going to say 1 plus 2 plus 3, 6. Is there a negative in the front? No. Okay, so look at the front page of your notes. We have an even degree with a positive coefficient. So which way do the arrows go? Up, up. Okay, up, up. So what I'm going to do is on my graph, on the very left side, I'm going to put an up arrow. On the very right side, I'm going to put an up arrow. Okay? So I'm helping myself figure out what the overall shape should be. Okay, what x-intercepts do we have? No, positive 3, negative 5. What about the x in the front? 0. Okay. What is the multiplicity of the x-intercept of 0? What's the exponent? 1. Okay, multiplicity 1. What's the multiplicity at 3? 2. What's the multiplicity at negative 5? 3. Okay, so now I go through and I say I have an x-intercept at 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I need you to always put the little lines there to count, because if you don't, then it's a problem like number 13. Did you guys do number 13? And if you don't label it, I will. And my favorite is to label it in the 1000s, and then you get it wrong every time. Okay? So if you don't label it, I will, and I will label it wrong. And then you will not get credit. So you test it, you just won't get credit. So label your problems, okay? So everybody should have those little lines in there, okay? All right, so it says at negative 5, we have to squiggle as we go through, okay? When we squiggle as we go through, we have 2 options, okay? So I have to make it make sense with that arrow, all right? Should I squiggle through like this? Would that make sense with having an arrow over here? Or should I squiggle through like this? Yeah, the second one, right? The second one makes more sense. Okay, so what I'm going to do is I'm going to go ahead and erase this and make it look nicer. And I'll go ahead and I'll do this in color so you guys can see. So I'm going to go through like this, and that has my left arrow up at the top, which is what I wanted it to have, right? Okay, at the 0, I have a multiplicity of 1, so I have 2 options. I can slant up to the right like this, or I can slant down to the right like that. Up way, right? It makes more sense. So if I'm drawing this one, it makes more sense for me to do this. And you can see that it makes more sense because it's easier to connect the 2 lines together. Okay, when you connect these, we always connect them with a smooth curve. So I should not see anyone connect it like this. That's not how these graphs look, right? When you looked at them, they never looked like that. We always connect them with a smooth curve. So it should go like that, smooth curve. Okay. The next one is our multiplicity of 2. And we have 2 options. We can have a parabola underneath, or we can have a parabola above. Which one makes more sense? Above, right? For it to end up with that arrow, it has to be above. So I'm going to say, here's my parabola above. I have that right arrow that I'm ending on. And then how do I connect these 2 together? Do I just draw a straight line connecting them? Make sure it's a smooth curve. Okay. Does that make sense? Okay. Let's try another one. So for this one, what exponent should I put on the parentheses? 1. So this has a degree of 3. 2 plus 1 is 3. We have a negative in the front. So on the front of your notes, you're looking at an odd degree with a negative coefficient. Up, then down. Okay, so I'm going to put up, then down. Okay. What x-intercepts do I have? Negative 5. X equals negative 5, x equals 0. The negative 5 has a multiplicity of 1. The 0 has a multiplicity of 2. Okay, so I've got 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So for the multiplicity of for the x-intercept of -5, I have a multiplicity of 1. Should I slant through like this? Or should I slant through like this? The second one, right? The first one doesn't make sense because then it would have to like backtrack to connect to the arrow. So I'm going to say that my multiplicity of 1 going through x minus 5, or sorry, pause, -5 for x, should look like that. And then it should have an arrow, right? That makes more sense. We have a multiplicity of 2 for this one, so does it make more sense to have a parabola that's above or to have a parabola that's below? Below makes more sense. Okay, so I'm going to go ahead and connect this. Parabola below, I can draw my arrow going down, and then what should I do to connect these? Smooth curve. What an awkward thing to say. Shall we do the next problem? No, we're going to do all 6, so we're just going to say yes every time. All right, what's the degree for this one? Yes.
Degree is 4.
4. And let's figure out which way the arrows go. Arrows go up, up. So it's an even degree. It has a positive coefficient, so the arrows go up, up. All right, what x-intercepts do we have? -3 and +4. And what is the multiplicity for each of them? Both of them are 2. Okay, so we're going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And our arrows are up, up. Okay. So for the x-intercept of -3, we have a multiplicity of 2. Should we have a parabola above or a parabola below? Above, because it has the up arrow, right? So above is the only thing that makes sense, okay? So we have, it's going to look like this. Okay. And then for an x-intercept of 4, we have a multiplicity of 2, so that's a parabola. We can have a parabola above or below. Above makes more sense to connect to the arrow. And then in between, I just connect these, right? Straight line. No, that looks weird. Smooth curve. Ta-da. Yeah, okay. What's the degree of this one? Degree is 5. All right. We have a negative coefficient, up and then down. What are the x-intercepts? 7 and 0. 7 has a multiplicity of 2. 0 has a multiplicity of 3. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And we have up arrow first, and then down arrow. Okay, so we have 0 with our multiplicity of 3. So one way we can draw it is we can go up, level out, go up. Does that make sense? No. Or we can go down, level out, go down. That one made more sense. Okay. So multiplicity of 3, go down, level out, go down. Everyone okay with drawing their multiplicity of 3? That's the hardest one to draw. So we went down, then we leveled it out, then we went down. And then the other one we have a parabola or a parabola. Down. Down makes more sense. So parabola that goes down. And then how do we connect them? Smooth curve. All right. Next one. So we got our ones in there. 6. The degree is 6. Negative in the front. Down, down. How many x-intercepts do we have?
1, 2, 3, 4.
Okay. So we have an x-intercept of -5. What's the multiplicity? 1. Okay. X-intercept of -1. Multiplicity is x-intercept of 2. Multiplicity is 3. X-intercept of 5. Multiplicity is 1. Okay. So 1, 2, 3, 4, 5. -1, 2, 5. And the arrows go down, down. Okay. So at x equals -5, we have a multiplicity of 1, so we're going to go straight through. Should I go straight through, or should I go straight through? The second one? Because if you do the second one, then you have to go back. So the first one, we need the first one. Okay. So we're going to do this way. Okay. At -1, we can go straight through, or we can go straight through. The second one, okay. So we'll go straight through like this, and then we got to make sure we connect them. Okay. All right, and then for the x-intercept of +2, we have to do the s. So should we go down, level off, go down? No, that doesn't make sense. So we're going to go up, level off, go up. That makes more sense. So up, level off, go up. Okay, and then last, we have a multiplicity of 1. So should we go straight through like this, or straight through like this? Second one? So straight through, arrow goes down, and we connect with a smooth curve. Are yours looking pretty?
Yes.
Do they look nice? Nice little, no? Some of these end up looking real ugly when I see them. It looks like somebody was drawing it, and they were like, this is my multiplicity of 3, and they were like drawing it, and they were like, and that's what their graph ends up looking like. All right. What's the degree for this one? 9, okay. Which way do the arrows go? Ooh, we don't agree. Ooh.
Up, down, because it's negative and odd.
So it's odd. So it's up, then down. Okay. What x-intercepts do we have? Okay. 0 has a multiplicity of 3. -4 has a multiplicity of 3. 2 has a multiplicity of... It's almost like everyone hates drawing them. Huh? Okay. Dylan, this is what you act like when you're not feeling well?
I'm still normal. Dang, Dylan. I might need to come live with you guys because my mom will be like, hey, no, you're at school. You staying at school.
Dylan, you're not feeling well?
Dylan, I'll pray for you.
Dylan, are you pretending to act sick now? Well, I mean, before you were very chipper, now you're like, I mean, I'm not feeling great.
I'm still going to talk to people.
Uh-huh.
Bye, Dylan.
Bye, Dylan.
Hey, remember the smooth curves.
Goodness gracious. All right, so we got the up arrow.
I think we should just end that class.
We got the up arrow, we got the down arrow. We're all very sick in this room right now. All right, so is this how we should be drawing the first one? Does that look right? That's how it should look? Yeah, definitely not that one. Okay, so -4 should be down, level off, down. Because we already see that if we did the other version, it would look weird. Yeah, doesn't make sense. All right, for this one, should we do up, level off, up? Or should we do down, level off, down? Up, okay. So up, level off, up is what we should have for that one. And then we connect it with smooth curve. Okay, and then for the last one, should we go up, level off, go up? No, down, level off, go down. This one's gonna look weird. Okay, so go down, level off, go down. And then you have to be very careful to make sure you connect it with a curve. Yeah. All right. Whew, we made it. Okay. So we're going to go ahead and start working on our packets again with drawing our own.